Hello and welcome to Mrs. T's Chem Talk Regents Review. This will be another review for the blue exam, which happens to be January 2014. And in this video, we will cover questions 31 to 50. Okay, so looking at question 31, this question is asking which ion has the smallest radius. And remember that for just some background information, if we're talking about metals tend to lose electrons and they form positive ions that are smaller than the atoms. But these right here are not metals. These right here are nonmetals. Nonmetals tend to gain electrons to make negative ions, and these negative ions tend to be larger than the atoms that they came from. So one of the things that we're going to need to look at when we're deciding whether these ions are the smallest or the largest is that we are going to need to look at the periodic table. So if we just take a look at the periodic table, all of these are -2 ions. So since each one is a -2 ion, that means that they each have gained 2 electrons. But if we look at the periodic table, let me find the periodic table. If we look at the periodic table, notice, and I know this is sideways, but if we notice, oxygen is at the top, then S, then Se, then Te. So what that means is that Te with a -2 will have the same electron configuration as xenon, but with 52 protons. Oxygen with a -2, will have 8 protons, but will have the same electron configuration as neon. So the O-2 will be the smallest because it has 2 shells. The Te-2 will be the largest because it has 1, 2, 3, 4, because it has 5 shells. So they're asking for the smallest radius. That will be the O-2, and that again is because they all have the same charge. Each atom gains 2 electrons to become the -2 or 2 negative ion, and O2 with a -2 charge has 2 shells, whereas each subsequent choice has another shell, and more shells means larger radius. If we look at number 32, in number 32 it says equal amounts of ethanol and water are mixed. Hold on 1 second. Equal amounts of ethanol and water are mixed at room temperature at 101.3 kilopascals. Which process is used to separate the ethanol, that should say, from the mixture? So ethanol and water are 2 different substances. And since these 2 different substances will have different boiling points, we can use the process of distillation to separate anything that has different boiling points. We also happen to know that, just as a side note, that the stronger the intermolecular forces of attraction, the higher the boiling point for a substance, and that weaker intermolecular forces means a lower boiling point. The substance with the weaker intermolecular forces and the lower boiling point will be collected first from distillation. Looking at number 33, it says that a sample has these characteristics. It says that the melting point is 984 kelvins. It is hard. It is a brittle solid at room temperature. It's a poor conductor of heat and electricity as a solid, and it is a good conductor of electricity as a liquid or in aqueous solution. This sample is classified, as we can see, as an ionic compound. And the reason why this sample is classified as an ionic compound, or the big telling indicator here, is that ionic compounds do not conduct in the solid because their ions are held in fixed positions when they're in the solid. But in liquid and aqueous solution for ionic compounds, the ions can move. And we said that in order to conduct electricity, a substance needs to have a mobile charged particle. And for ionic compounds, the ions can only move when they are aqueous or liquid. And when the ions can move, the ionic substances can conduct electricity. We're up to number 34, and it says given the balanced equation representing a reaction, which statement describes this reaction? So we see that we have a represented here when the subscript is after, these two ends are connected to each other. So what this represents is actually a mole of N2 molecules. Remember that N2 is one of our diatomics that has this triple bond. When we write them separate like this, notice that now there is no bond anymore. So they're separate from each other. So what this means is that a bond has been broken. We used the acronym BARF, B-A-R-F, for when bonds are broken, energy is absorbed, energy is released when bonds are formed, and we said that absorbed means endothermic. So the bond is broken and energy is absorbed, which means endothermic. For the next question, up to 35 now, it says that when lithium reacts with bromine to form the compound LiBr, each lithium atom. So lithium is our metal, and a lithium atom has one valence electron. Bromine is a nonmetal, and on the periodic table, bromine's electron configuration ends in 7. So that means that bromine is going to gain an electron to go from 7 to 8. When lithium gives away its valence electron, its charge becomes a positive 1. And when bromine gains an electron, it now has its stable octet, and its charge is a negative 1. So the lithium atom, which is right here, loses its valence electron to become a lithium ion, and we said that losing is positive, and we said that gaining is negative. If we move up to number 36, it says that a beaker with water and the surrounding air are all at 24 degrees Celsius. So we have 24 degrees Celsius out here, and we have 24 degrees Celsius in here. And they're asking if we put ice cubes into the water. Now the ice cubes have to be either at 0 degrees Celsius or something lower than 0 degrees Celsius. Heat will always travel from high temperature items or objects to low temperature. So the heat from the outside surroundings doesn't go to the water because they're actually at the same temperature. They're actually at what's called a thermal equilibrium, where the heat does not the heat does not travel in one direction or the other. They're at the same temperature. Now, or it doesn't travel more in one direction than the other because they're at the same temperature. Whereas the ice is a lower temperature than the surrounding water, so heat will go from the higher temperature water into the lower temperature ice cubes. Looking at number 37. Sample of chlorine gas is at 300 Kelvin and 1 atmosphere. At which temperature and pressure would this sample behave more like an ideal gas? We said that this is your ideal vacation situation where gases will behave most ideal at high temperature and low pressure. So you're looking for the highest temperature of the 4, which was 600, and the lowest listed pressure, which 2 of them were at 150, but this one was also at 600. So high temperature and low pressure allows the gas molecules to be as far away from each other as possible, allowing them to not succumb to the deviations. Remember, they get real gas molecules deviate because of interactions, forces of attraction, and because of individual volumes. And the further away we can get those gas molecules from each other, the less those deviations are a problem. 38. When a sample of a gas is heated in a sealed rigid container from 200 kelvins to 400 kelvins, the pressure exerted by the gas. So this is sort of an indirect P1 V1 over T1 question. And they're telling us that it is a rigid container. So that's our clue that the volume can't change. So they're saying that when we double the pressure, what happens? When we double, sorry about that, let me go backwards. So in this question again, we're changing the temperature. This is an indirect P1 V1 over T1 question equals P2 V2 over T2. We are talking about a rigid container, which means that our volumes are not changing. They want to know what happens to the pressure when we double the temperature. We know that the relationship between temperature and pressure is that as temperature goes up, pressure goes up as well. This is a direct relationship. So if we double the temperature, we will also double the pressure. For number 39, it's a bright line spectrum question, and they give us these bright line spectra for different elements, and the question asks about these two elements. The question is asking which elements are present in the mixture. So now we have this whole list here of different elements. We have element A, we have element D, we have element X, and we have element Z. Now, element A has its first line. This is what, 10, 90, 80, 70, 60, 50. So it has its first line at 90, 80, 70, 670 nanometers. Now, I have a line at 670 nanometers in the mixture. Its next line is at 610. This one has one at 610 as well, and it has one at exactly 500. The mixture has one at 500, and it has one at 460, which the mixture has one at 460. So that right there tells me that element A is completely represented in the mixture because all of the lines from element A are down here represented. So now what we need to do is say, okay, well, where did these two lines come from? These two lines are at 590 and about 585, and element D has 590 and 585. So that is what tells us, that's the definitive proof that this mixture has both element A and element D. All of element A's wavelengths are present. All of element D's wavelengths are present. So if we look at the choices, A and D are what are present in the mixture because they each had all of their wavelengths in the mixture down below at the bottom there. Looking at number 40, the graph below represents the relationship between time and temperature as heat is added at a constant rate to a sample of a substance. Now we have three slanted lines. That means that this slanted line is the solid, this one is the liquid, and this one here represents the gas. That means that AB is what represents our melting. And the next line here from liquid to gas is our boiling or vaporization line. The slanted lines represent when kinetic energy is changing because the temperature is being shown to change. And my phase changes are when potential energy is changing, but kinetic is remaining the same. If temperature doesn't change, kinetic energy doesn't change. We also have at our two phase changes, we have an equilibrium between the two phases. So we have solid and liquid both present, and there's an equilibrium at melting. Here, liquid and gas are both present when we're at the boiling line, and both liquid and gas are both present. You should also note that the length of the line when we're talking about vaporization or boiling is longer than the length of the line for melting because it requires more energy to boil a substance than it does to melt it. We're overcoming the complete intermolecular forces of attraction when we are boiling. So AB, we said was, going to the question now, AB we said was the time when we had melting happening, and so the potential energy of the of the particles increases. 41, given the potential energy diagram for a reversible chemical reaction. So what we should notice when looking at this potential energy diagram, we know that the reactants are where we start. We go up to the top, which is the activated complex, and then we come down to the products. So we start at reactants and we go up to the activated complex and come down to products. Now in this particular potential energy diagram, the products have more potential energy than the reactants. So this here is going to be an endothermic potential energy diagram. Since it's endothermic, that means that there will be a positive value for delta H because we always do the value for the products minus the value for the reactants to get the delta H. If we look at the question is asking for each interval on the axis labeled potential energy represents 10 kilojoules per mole. What is the activation energy of the forward reaction? So when we're talking about activation energy, we have to go from the reactants to the top. The forward activation energy would be from the reactants to the top. And even though they weren't asking about it, if they were asking about the reverse activation energy, that would be from the products to the top. So I'm going to erase that one because that's not what they're asking about. So they said that each box is 10. So this is 10, 20, 30, 40 kilojoules per mole when we count it out on the graph there. So the activation energy is 40. For number 42, which condensed structural formula represents an unsaturated compound? Remember, unsaturated means that there is a double or at least one triple bond present in the molecule, and that happens when the sum of the atoms is either double the carbons to get the hydrogens or less than double the carbons to get the hydrogens. So the molecular formula of the first one is C123 C4 H3 4 5 6 7 8. It's butene. That has a double bond. How did I know? Because 4 doubles to 8. Carbon was 4, hydrogen was 8. When you double the carbons to get the number of hydrogens, you have a double bond. For each of these, C3, H8, C2, H6, and CH4, for each of these, it's CnH2n plus 2. These are all alkanes. Alkanes are saturated. Single bonds represent saturated hydrocarbons. 43, which element will react spontaneously with 1 molar HCl at room temperature? This is a table J question. Any element above hydrogen, so any element on table J that's higher than hydrogen, will spontaneously react with an acid because it's more active than the hydrogen. And if we look at table J, which is going to be back this way, if we look at table J, any element that's higher than hydrogen will do this. And so if we look here, it's hydrogen, it's all the elements up here, and the choice zinc was right here. For number 44, given the balanced ionic equation, what is the number of moles of electrons gained by 3 moles of lead ions? When they give you a number of moles for lead, that means they want you to use that coefficient when you write your equation. So we have 3 Pb plus 2 turning into 3 Pb0. This is reduction because the electrons are being gained and the charge is going down, +2 down to 0. And we said that for reduction, the electrons are going to go before the arrow. What they're asking is what number, what coefficient goes in front of the electrons. So this side has a total charge here, 3 times +2 of +6. This side has a total charge of 0. We need a -6 to balance out the +6 so that both sides add up to 0, because this is the only product over here and it has a total charge of 0. So that means that there are 6 moles of electrons. Another way to do it is that PB goes from +2 down to 0. That's a difference of 2, and it has to happen 3 times. 3 times 2 is that 6 for the coefficient of the electrons. For number 45, if we look at the question, it says, what is the amount of heat energy released when 50 grams of water is cooled from 20 degrees Celsius to 10 degrees Celsius? This is a heat question. We're going to use the formula Q equals mc delta T. Q will represent our heat. M is the mass of water, which is 50 grams. This formula, remember, is on table T. The C value is 4.18 joules per gram Kelvin. This is on table B, the constants for water. And the delta T, remember that symbol delta means subtract, so that means that we're going to put in a 10 degrees Celsius here. When you multiply out and get your answer, we wind up with 2,090 joules, which is the same thing, 1, 2, 3, as 2.09 times 10 to the third joules. That would be a scientific notation way to write it. For number 46, what occurs at one of the electrodes in both an electrolytic cell and a voltaic cell? We said that we use an ox and big red cat to remind us that the anode is always oxidation, reduction is always at the cathode, and the cathode always gains mass, always gets larger. And oxidation occurs as electrons are lost at the anode. We also know that oxidation is Leo up and that reduction is Gerd down. Losing electrons is oxidation and the charge goes up. Gaining electrons is reduction and the charge will go down. For number 47, looking at 47, it says, given the balanced equation representing a reaction, according to one acid-base theory, this is going to be the Bronsted and Lowry, or also known as the alternate theory. And we see that H2O is matched with H3O on the other side, which means that H2O is acting as a base because H3O is its conjugate acid. Acids always have more H's. And then HCl and Cl minus, HCl has the extra H, so it's the acid. Cl minus has less H's of that conjugate pair, so it's the base. Now that means we can also go with our BAAD. Bases accept H+, acids donate. If this is acting as a base, it's acting as a base because it's accepting H+ ions. For 48, we're almost done with the up to 50 here. 48, when an atom of an unstable isotope Na24 decays, it becomes an atom of magnesium-24 because the Na24 spontaneously releases what? So Na24 is going to look like this. Mg24 will look like that. I'm going to leave those on the screen while we switch over to the periodic table so we can look and see what the Na24 is not one of our choices on table N, so we're going to have to figure this out mathematically. So let's look on the periodic table and see what Na and Mg have for their atomic numbers. So Na is number 11 and Mg is number 12. So I'm just going to put that here. Na is number 11 and Mg is number 12. And then we'll go back to where we were. And if this is going from 11 up to 12, that means it must give off a particle that has a -1 here, because 12 with a -1 gives you 11. So this is a beta part our equal sign. Spontaneously means that this is the only species before the arrow. And in order for the top numbers on each side, the mass numbers on each side, and the atomic numbers on each side to add up to the same totals, this missing particle would have to have these numbers on the top and the bottom, which is for a beta particle. You could also look at table O to find that symbol. Number 49, which balanced equation represents nuclear fusion? Fusion is always going to be H plus H makes He. There might also be a neutron in the products, but you will always have some isotope of hydrogen, plus giving off helium here, and sometimes there's also a neutron. Remember that nuclear fusion happens on the sun. There's a tremendous amount of energy released because of nuclear fusion, and the two nuclei that are uniting in the reactants, we need a tremendous amount of pressure and heat to get them together because they're both positively charged and they both repel each other. And finally, the last one for this video, which reaction releases the greatest amount of energy per kilogram of reactants? Remember that any nuclear reaction will give off a lot more energy compared to a chemical reaction because there is a small loss of mass, but that mass is not destroyed because that would violate our laws of conservation. That small amount of mass is converted into energy for any nuclear reaction. There will always be a small loss of mass because that mass is converted into energy. So hopefully this was helpful. This was 31 to 50 on our next exam that we've been working on. And it was the blue exam, which was January of 2014. So hopefully this was helpful. Please check out the other videos that are on the YouTube channel, Mrs. T's Chem Talk, if this was helpful, and happy studying.